Today we are going to be writing equations of lines in slope-intercept form again, but these lines we're going to make perpendicular to a given line that passes through a given point. So to figure out this big concept behind perpendicular lines, it's a good idea to graph two lines that are perpendicular. So let's start with this one here. We've got our y-intercept of positive 2. So I'm going to go up 2 spaces. Put a dot right there at positive 2, and then follow the slope. So here, the slope of this line, m, equals 3/5. So that's where I'm getting this number. The slope of the line tells me to go up 3 spaces, and I go right 5. So I'm going from this point up 3, 1, 2, 3, and then over 1, 2, 3, 4, 5. I could also do that again going the other way. I could go down 3 spaces and then over 5 to the left. 1, 2, 3, 4, 5. And what that would represent is a negative 3 over a negative 5. Two negatives also make a positive, though. And so we could go ahead and draw the line between those points. And if we're real careful, we get it right between those lines, we'll have a nice line. Put some arrows at the ends, symbolizing that it goes on forever in that direction. Well, let's take a look at the next line here. We have the y-intercept of -1. So we're going to start down 1 space on the y-axis, put a dot there, and then follow what the slope tells me to do. The slope here is -5 to 3. So this tells me to go down 5 spaces, but then I go to the right 3 spaces. So down 1, 2, 3, 4, 5, and then right 1, 2, 3. I could also go the opposite direction. Again, that would be a 5 over -3, because just one negative makes a negative. So I could go from this starting point up 1, 2, 3, 4, 5, then over 1, 2, 3, and then put a dot there. And then what you'll notice is that if I draw a line between these points, we have a right angle. And that's what we have when we have perpendicular lines. So this angle between the green line and the blue line is what we call a right angle, 90 degrees. And 90-degree angles, well, we have perpendicular lines that form them. So we have a symbol here for perpendicular. This symbol for perpendicular lines is an upside down T. And that way you see a vertical line and a horizontal line. The angle in between is perpendicular, is 90 degrees. Well, anyhow, if we take a look at their slopes, the slopes of these lines, we have one of the slopes was 3/5. So if I write that one down, that blue line had a slope of 3 over 5. Well, the perpendicular slope, so here's my symbol for perpendicular slope would equal, and then it's the opposite and reciprocal. That's what I have written down here, the opposite and reciprocal slopes. And so if you look at that, the opposite was negative, because this was a positive 3/5, so the opposite is negative. The reciprocal is 5/3. And that's the key that we're going to end up looking for, is that we need to take the opposite, which was the negative in this case, because this one was positive. So here we had positive, and then over here we had negative. So you can see that we had opposites. And then reciprocal meant that we turned the fraction upside down. So here it was 3/5, here it's 5/3. And that's what we're going to end up having to do in order to figure out what slope to use. So let's take a look at the problem that we end up having here to start with. Here we have an equation and a point. Well, what we want to do is find out what the slope is. Well, we know this slope of the line is -2. That's what it says right here. It's because if y is by itself, I know the slope is the number out in front of x. It's what changes x. But I don't want that slope. I want the perpendicular slope. So the perpendicular slope equals, well, it's the opposite sign, so it's positive, and it's the reciprocal. So it's 1 over 2. So 1 over 2, that's the slope I'm going to end up using. So we're going to end up writing out our point-slope formula, y minus y1 equals m times x minus x1. And we're going to substitute. We're going to put that 1/2 in for m, the -2 in for x1, and that 5 goes way over here in for y1. And so we go ahead and do that substitution. Here's what we get to write down. We've still got our y, and then it's a -5 equals 1/2 times x minus -2. Well, we go ahead and do some work there. Again, anytime you see that minus negative, right away I'd change that to plus positive, and then I distribute that 1/2 over that addition. So we can rewrite our problem from here. We've got y minus 5 equals now 1/2 x, and it's going to be a plus 1. Now the way I get that is 1/2 times by 2, and I can treat 2 as a fraction by writing it as 2 over 1. The 2's end up cross-canceling, and I'm left with 1. 1 times 1 gives me 1. Well, we've got another step here, and the last step is to do some opposite operations. So it's a -5, so I'm going to add 5 to both sides. And so when I do that, now I've got my answer in slope-intercept form. I've got y equals 1/2 x plus 6. And there it is. So the key on tonight's homework that's different from last night is we've got to get that slope, but we're not going to use the slope we're given, because that would be a parallel line. We're going to use the opposite and reciprocal slope. So taking a look at this next one, we need to get the y by itself. And so the way I'll do that is divide by 3. The trick is you got to divide every number by 3. If you do it to one side, all numbers need to be divided by 3. So what do we have? Well, when we rewrite this, we've got y equals, now x divided by 3. What number can I put right next to the x? Hopefully you said a 1. So that's 1 over 3. And so it's 1/3 x. And then this would just be minus 4/3. Well, here's the slope I've got, 1/3. But I don't need that slope. That would be the parallel slope. Parallel slopes are the same. I want the perpendicular slope. So what slope am I going to use? Well, remember, it's the opposite and reciprocal. So here's my symbol for perpendicular. The perpendicular slope equals, and then I write down the opposite sign, so it's negative, and then the reciprocal, 3 over 1. So that's just -3. That's the slope we use. So we can go ahead and rewrite our equation in that point-slope formula. So I'm just going to substitute the numbers into that y minus y1 equals m times x minus x1. Well, here's my x term, here's my y term. So I'm going to rewrite this as y minus -1 equals the slope that I'm going to use, that -3 times by x, and then I'm going to use this 2 here, minus 2. And so I use that distributive property, multiply that -3 over that subtraction, and I'm also going to change that minus negative to plus positive. So we can go ahead and rewrite what we've got then. We've got a y plus 1 equals, and then I'll write that as -3x plus 6. So you see a negative times a negative made a positive. So I got one more step here. I need to move that 1 back to the other side. So I'm going to take 1 away from both sides. And so when I do that, I can rewrite my problem in slope-intercept form. So that would be y equals, and then I still have that -3x, now it's plus 5. I had to subtract because they're opposite in sign. So there it is. So this line is perpendicular to the line that we started with. Again, look at the slopes. They're opposite and reciprocal. Well, here's a more challenging problem. This one has one where we need to get the y by itself, but we've got more steps involved in it. And so it's because we have this 5x. I need to move the x term over. So I'm going to do an opposite operation here. Take that 5x away from both sides. So when I do that, I can rewrite this as now 2y equals, and I still have that negative 5x because I can't combine it with the 10, so I'll write that first, because typically we write our x terms first and our constants last. And so it's a positive 10 because there's no sign in front of the 10. Well, the next step would be to get rid of that 2. So to get rid of that 2, I divide by 2. Now I'm going to divide every number by 2. And what's left over? Well, let's see. Well, first of all, y's by itself now, so we'll be able to figure out what that slope is now. And we have negative 5 halves x, and then 10 over 2 makes 5. So now we can figure out what our slope is. Well, our slope is the number out in front of x. But that's not the number we're going to use. This just tells me what the slope of this line is. That is the parallel slope. We don't want the parallel slope. We want the perpendicular slope. So this is my symbol for perpendicular. M stands for slope. And this is obviously an equal sign, and it would be the opposite of a negative, which is a positive. And then we have the reciprocal, which is 2/5. So positive 2/5. That's the slope I'm going to use. So now, let's go ahead and take our point-slope form, this y minus y1 equals m times x minus x1, and we're going to use this point. So remember, this is our x value, this is our y value, and we're going to use this slope. So we're going to rewrite y minus, and then I use the 3, equals the slope 2/5 times by x minus negative 5. So again, all I'm going to do is, anytime I see a minus negative, I'm going to change that to a plus positive. And then from there I need to distribute. Distribute that 2/5 over that addition. So when I do that, here's what I've got left. I've got y minus 3 equals 2/5 x, and now this is going to be a plus 2. Let's see how. See, if I rewrite this, 2/5 times by 5. Well, I can treat 5 as a fraction. 5 over 1. See how those 5's cross-cancel? They make 1 when you divide 5 into 5. 2 times by 1 gives me 2. So that's how I got that number. One more step here. Just move this 3 over. So the way I do that is, that's a minus 3, so I need to add 3 to both sides. So I go ahead and do that, and now I've got my answer. I've got y equals, and then I write down 2/5 x plus 5. And there it is. I've got my answer in slope-intercept form. So the next part of the lesson is a little review on seeing if a point is actually on a line or not.